Click the bell icon to get latest videos from Ekeeda.
Hello friends, welcome back to the subject of Machine Design 1. We are right now working on a numerical which is based on the design of springs against fluctuating and static loads. In the last session, if you remember, we had designed the spring and found out various parameters related to the spring based on the static loads given. In today's session, we are going to look at the fluctuating loads, the effects, and some important parameters we are going to find out. So let us proceed. As we know that in this particular case we have been given two different forces, a maximum one and a minimum one. Now considering these two forces, we need to find out the main force and the amplitude force, based on which the further design is based. So these are the two important factors which we are going to use. We again have been given the shear stress value, which is the moderate one or the mean one, is given by this particular formula. We already have found out the value of Ks, which is somewhere equal to 1.0833. So this is the value based on the mean value of the forces. Let's proceed for the amplitude value of shear stress, which refers to the amplitude value of the force. Somewhere equal to 95.68 Newton per millimeter square. Now based on this, the further calculation is based. Generally, our curriculum is expected to find out only factor of safety, not more than that as far as this particular example is concerned. So we know that the diameter of wire that we have assumed so far, the value of sigma u comes out to be, and therefore the values of stresses we can find out. The value is the yield value and another one is the yield value of its endurance limit. As we substitute these values, with this particular thing, let us proceed to the empirical relation that we have. This is a famous relation that you will obtain in the design data book also, and it connects the value of shear stresses at amplitude and mean value of the forces with the factor of safety and the yield stress and with the extreme level of this particular stress. And therefore, as we substitute the values, as we solve this expression where only factor of safety is unknown, the value of factor of safety comes out to be 1.46. Now students, generally factor of safety amount or the value of factor of safety as far as the springs are concerned should be somewhere below 1.5. In that case, it will be a desired condition. You can see that in our case also the value is below 1.5, and therefore we can say, since factor of safety smaller than 1.5 and of course greater than 1, therefore the given design is safe. So there we complete with the numerical, and we have found that the selected wire diameter and associated parameters for the given loads is safe. So let's quickly summarize the output of our problem. So final design specifications: the material is used in such a way that it's oil hardened steel. The wire diameter which was found out was 5 millimeter. The mean diameter of the coil was 30 millimeter. The free length was somewhere around 144 millimeter. Total number of coils were 21, and the ends are square ends of this coil. The last parameter not to forget is the factor of safety, and which is 1.46 in our case. So there we finish with the numerical, where we had assumed the index factor of the spring is equal to 6, and accordingly for the selected material, that was oil hardened steel, we have found out the wire diameter is 5 millimeter, and the rest of the parameters were found safe. So that was from my side. Next time we'll be looking at the design aspects of lip spring. Thank you so much for watching this video. If you like this video, please subscribe to Ekeeda.